Working as assistant professor in the Department of Mechanical Engineering in St. Peter's Engineering College. In today's class, let us learn how to perform a model analysis on a 3D shell. Let me read the question first. Conduct a model analysis on a cylindrical shell with 17 mm thickness and 2.5 mm diameter. Okay, for that, let me first go to preferences, structural, H method, click OK. Preprocessor, element type, add, go to shell, 3 node 181, click OK, click close. Go to material properties, material models, structural, linear, elastic and isotropic. Here enter the Young's modulus value as 1.3 e to the power of 9 and Poisson's ratio as 0.45. Click OK. Go to density, enter 900, click OK, click close. Okay. Now go to sections, shell, lay type, add, here add the thickness, click OK. Now go to modeling, create lines, arc by center and radius, enter the center as 0, 0, 0, click OK. Now enter the radius as 2.5 e power minus 3. Click OK. So here it is 360 degrees, we need 360 degrees, click OK. So a circle will be created like this, and here you will be having 4 points, first, second, third and 4 points. So whatever the point we are going to create next, that should be named as fifth point. Now go to key points, in active coordinate system, name this point as fifth point, and here the fifth point is 2.5 e power minus 3. This column is 0 and this is 17 e power minus 3. Click OK. So this line has been created, this point has been created behind this points. Now let me change the view to isometric view here so that you can see. So this is the fifth point. So this point is straight to point number 4. So now what we do is we join these two lines, that is we will join these 2 points, the fourth point and the fifth point. Now create lines, straight line, pick this point and pick this point, click OK. So we have created a line like this. Now we need to create a 3D shell using these points. So for that, go to operate, extrude, lines, along lines, click here, 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 click OK. Again click on this line, click OK. So like this a 3D shell will be created. Now we have to go for meshing this shell. Meshing, mesh tools, go for mapped mesh, click on mesh, pick all the points. Now the entire figure got meshed. Now go to solution, analysis type, new analysis, click on model analysis, click OK. Now go to analysis options, here type as 30 and here also type as 30, click OK. The frequency ranges from 0 to 6000, click OK. Now define loads, apply structural displacement on nodes. So keep on any view which is convenient for you. Now here I am picking a box. So all the points which are in this box will get selected, click OK. So here I am bonding UZ. Click OK. So I have bonded this. Now go to solve. Solve current LS. Click OK. If you get some note as solution is done, then what the process you have made is right. Okay, if there is any error when you are making the analysis, then that error will be shown here. Now close it. Go to general post processor, read results by pick. So here you have some frequency, you can choose any frequency which you want. Click on read and then close. Now plot results. Counter plot. Not this. Yeah, here it is, deformed shape. Go for deform plus undeformed shape, click OK. So this is how the 3D shell looks on application, means at that particular frequency. In the sense, see here we have bonded this area, and then we are studying how the 3D shell is getting deformed with respect to time and at different frequencies. So at different frequency there is some deformation, and that deformation can be seen here. So here, if you want to see only deformed shape, see this is the deformed shape. And if you want to see deformed plus undeformed shape, see actually it should be here and it got deformed here. So like this you can see deformed plus undeformed shape. So this is the actual figure, means wherever you are finding white lines, that should be the actual figure, and it got deformed here in this way. So whatever the blue linings that you are finding here is the figure of the deformation. So this is how we'll perform the model analysis. So here you can see at what frequency what is the deformation that you're getting. So here it is showing you the frequency value and also the maximum deformation here. So that is how we perform the model analysis. That's all for today. Thank you.